2. Good here. I'm a few minutes late. Oh. All right. Okay. We're now alive. Let me just turn this off so I don't get a bunch of notifications while we're doing this. Okay. I think we're good. I'm just going to turn off the phone as well. And here we go. Okay. All right, so yesterday I had started splitting up my code into different files so it would be a little bit easier to navigate. And I also set up debugging, which was not that trivial of a task. But now it's working, so we're ready to start writing some unit tests, I guess. That's what I wanted to do. For my AI bot, specifically the Monte Carlo tree search algorithm, I have implemented the Monte Carlo tree search algorithm before. I've never properly tested it using unit tests, and I have no idea how to go about that. That's going to be interesting. So let's think here. If we're looking at the overall algorithm, we've got it here. We are, so one thing, like I'm wondering at what level, how do I want to define my units really here? I'm thinking that we should try and test the algorithm at each, I don't need this anymore. Actually, never mind that. How about this? Should probably test each of these. So the tree policy, the expand, the best child, the default policy, and the backup function. Of course, each of these functions also call their own functions inside, but okay, let's see. Let's look at tree policy and see what kind of unit test we could use. So tree policy. The tree policy is basically the part of the algorithm where we traverse the tree. Let me just turn down the volume here for my music. Okay. All right, so if we're looking at the overall algorithm here, so it's the first thing that we do, right? We use the tree policy to traverse the tree, and that gives us the node that we're going to start our simulation from. And the simulation is the default policy here. So, okay. Tree policy, what does it do? Takes in a node, checks if that node is terminal. If it isn't, then it's either, depending on whether the node is fully expanded, meaning that we have created a child nodes for each possible action from that state, from that node. So if it's not fully expanded, we expand, meaning we create a new child node with one of the remaining actions that haven't been tried yet, that haven't been expended yet. Otherwise, we choose one of the children node, and that's what we return, and that's where we're going to be doing our simulation from. All right. So let's see if I do a unit test for this now, because I've got conditionals in here. That's going to be like a bunch of and by extension we'd be testing the find best child function as well, and the expand function as well. So really, I don't know if it makes much sense to test tree policy. Might be smarter to test these. Because the problem I see, if we test at the tree policy level, and it fails, it's going to be hard to know where it fails, right? Was it because it didn't do a good job with node is terminal? Is it because it didn't, properly determine if it was fully expended? Was it because it didn't expand properly? Was it because it didn't find the right best child? So I'm thinking we should probably test these in isolation. Yeah, but then again, you can always say that, right? Drilling down your functions until you get to a single, and then you end up testing every single function that does just one thing. It's a very philosophical thing when you think about it, testing. Oh, just give me a second here. Just want to open the door to my office because need the AC to come in. Getting a little too hot in here. All right. Because what would we end up testing if we're testing tree policy? We're just basically testing that tree policy, the plumbing basically of it, right? The conditionals. There's not much functionality here, is what I mean. So why don't we test at the same time? That's kind of implementation detail, right? Oh, it's so hard to decide what to do. All right, you know what? Let's keep it higher level, and really just test those main functions that we have here. They're the main parts of our algorithm. So it makes sense to test them. So I was going to say let's test tree policy first, but really tree policy calls expand and calls find best child, which are both very important functions. So let's test these first. So what we're going to do is test the expand function first. How's that? So MCTS, let's forget about that. Do I have another test here? No. So let's call this simply expand.test.ts. All right, so should I use now expand, let's think about this. Expand takes in a node. Which node does it take in? We're calling, expand is only called from the tree policy. It's the only place where we are going to be calling it, right? Yeah. So expand takes in the node that was fed to the tree policy algorithm and basically returns a new child node. So we just need to make sure that it returns the right kind of child node given certain states, certain nodes. So that's not too bad, really. Now, of course, expand takes in, uses other function, like it chooses an untried action at random. It applies the action. New node.addChild. Now I'm wondering if, so the Monte Carlo tree search algorithm is made up of different parts, and they're kind of all really important. If one of them is implemented wrong, the entire algorithm falls apart, but it's not obvious that it does because you're still getting results. You're just not getting the right results. And it's really hard to know that because it's based on randomness. It's not supposed to be perfect either, right? So how do you test for that? How do you really not that easy? Hmm. Right, because the interesting thing here, what can we test? We can test that given a certain node, expand is going to return a child node, but we need to make sure that it's not a child node that was already on that node. Uh-huh. I'm thinking that in testing something like the Monte Carlo tree search algorithm, you probably want to test the quality of your randomness too, right? Because so much depends on that. For instance, choose untried action here, which is on the node class. So let's take a look at that. Choose untried action. It's using a little helper function that I made called splice random, which is in here. Splice random is a function that removes and returns a random element from an array. Now, if I somehow implemented this wrong, and let's say, for instance, that I have a, some kind of an off by one error, for instance. Well, it would mean that, let's say, the first index in the array would never get spliced and returned, right? And that would affect the algorithm in a huge way, but it really wouldn't be very easy to find out, right? That to detect that bug. It would be quite hard, actually. So, we probably want to have some tests in expand. Did I just call this epand? Oh, rename. Oh, I want to try something. I gotta get used to using my hotkeys. There you go, F2. Shortcuts and stuff. Expand.test, yeah. All right. Enough of that. Let's write some actual code. So let's start with just this simple test that we're going to call, I don't know what we're going to call it. I have no idea. Expand test. For now, anyways. And let's see. It would make sense, though. So we need to pass in a node. So I'm going to need to create that node. If I want to create that node, I'm going to need a board. state. So let's use that. Cannot redeclare block scoped variable board. What are you talking about? Did I? Nope. Whoa, wait a minute. Why? Never had that before. Why are they not treating them like separate modules? It's like it's treating, if I'm not exporting it, why are you giving me this error? Right? What if I was to add a const board here equals 13? So it's not giving me a hard time here. Well, that's interesting. That is very interesting. What if I did the exact same thing for just for fun? And here, let's say. No, it's not giving me any problem. Oh, maybe. No, it's not even importing it from anything. Now that's interesting. Cannot redeclare block scoped variable state. Huh. That is intriguing. Very, very intriguing. Probably because there's no exports in here. Let me see, if I had like an export foo equals 13, would it be, I need a const, let's see. Yeah, okay. Okay. Interesting. Interesting. All right, well, in that case, let's do this. Describe something. Actually, we're going to call this expand test. Then that's going to be something else. Just, I don't know, expand, whatever. Like that. Like this. Bring that in here. And then if I put that in here, I shouldn't have a problem anymore. There we go. Okay. Now, I want to test that expand properly expands. How do I do this? All right, well, first I said we needed a new node, right? So let's call this const node. Const node. equals new MCTS node, pass in a state and an action. In this case, it's null. Really doesn't matter. Anyways, what we pass in there for the purposes of the expand. Does it? Wait, if it doesn't matter, then why are we passing it in? Hold on. Oh yeah, that's just okay. What are we using the node for? What are we using that action for? Oh yeah, we're just storing it because we're going to need to know what. Okay, that's cool. But for the purposes of the expand function, we don't really need it. Not that important. Although, yeah, it's going to be useful to assert. So anyways, but for this test, we're testing the very first root node, beginning of the game. There is no action that leads to the game state because the game hasn't started yet. So that's fine. We're passing in null. Now, what do we need? What do we need? Let's say, what would a test look like? Well, we would be calling our expand function, of course. So function, what am I saying? Expand, yes, expand. We're expanding the node. That's the only thing we need to pass in. Yes, we're expanding the node. Right on. So we're going to be receiving that's what we're receiving of type MCTS node. Node. Boom. What are we expected? Oh, that's going to be hard. See, that's the thing. Because this is using randomness. So there's two ways I can see that we get to test this. Either through choose untried action. Yeah, see, this is complicated. I've got two choices here. Either I mock this and let's take a look at this here. Right, choose untried action is the function that returns, that looks at the possible actions left to expand. And splices one from there and returns it. But it does so randomly, right? Splice random. So I never know which one is going to be returned out of the set, out of the array. So I would need to mock this function and return a very specific action. But then at the same time, that's kind of defeating the purpose. This is a very important part of the algorithm that we probably want to test. I don't know. Maybe, maybe not. Ugh. Testing can be so because I want my test to test something, right? If I end up mocking everything inside, then what am I testing? That is just doing the steps properly, which I mean is something, but I'm more interested in the actual behavior. Okay, the other option is to have our expected be the set of all possible actions, so of all possible nodes that would come out of that, and then we just assert that it's one of those. So that's one way to go about this. Yeah. Mm-hmm. But in the case of this test here, if we did that, we would have to provide our, our set of possible results would be 9 times. This is 9, so 9 times 9. Yeah, basically 81. There's no way I'm doing that, right? Ah, crap. Okay. That's why people don't test. Spend more time writing your test than actually implementing functionality. So I mock this. Apply action. I don't really need to mock that. That's fine as well. That's fine as well. So really the only one that I need to mock is this. But then I need to make sure that I'm actually testing this separately, right? So why don't I do that to make sure it does what we expect it to do? So why don't we choose? Well, why don't we start with that? Choose untried action. Let's think about this here. If I wanted to do that, I would have to use dependency injection. Either at the class level, which seems really weird. How would I do that? I could pass it in. All right, so here are my options. What if I wanted to return a specific action? From well, I could, let's see, expand. Choose on node, choose on tried action. This is more complicated than I thought it would be. So if I wanted to test this, choose untried action. What does it do? It looks at possible actions left to expand, which is an array of actions. It chooses one at random, and it returns it. So there's two things we would want to make sure this does, is A, that it returns an actual action from that set, from that array, and B, that it removes said action from this array. But since it's doing that randomly, how do I know? How do I know that it's doing that properly? I hate testing. mcts node.test.ts. Oops. Oh, so hot in here. Don't know what's going on. See if I can turn the AC up a little bit. All right. Sorry about that. Test. Okay, so what would I do to test that? I would need something similar to this, right? Because I need to create a node. Let's just use that then for now. And then, why is it type expected? Yeah. So we've got our node. We call node dot choose untried action. This would normally return. Oh, and here's the fun thing too, is that possible actions left to expand is private. And you want it to be. There's no reason why anyone in our code would call this directly. So how do you test that? How do you test that this was mutated properly? Grrr, I hate testing. So, maybe you don't, right? The usual answer is there's two ways to go about this. Either you make it public. Well, that's cheating, right? If we have to make everything public to test stuff, then what's the point of putting things private? So the other philosophy is you test the private stuff through your public API, blah, 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 blah. Okay, fine. So how do I test that I now have oh, well, I do have this. No, that's not right. Okay, never mind. I don't know, dude. I don't know how to do this. It's getting on my nerves. This is a function that at random returns one action from this array here. I need to test that this is working properly. And it's not only returning it, it's removing it from the array, right? It's splicing it. So how do I test that it's actually removed from this? I don't want part of this class API. I don't want something that returns this array. There's no need for that anywhere in the code. Why would I expose that? The only thing I need is this. But now I can't test this by using this. It doesn't make sense. Oh, testing is so hard. I don't know. I could just abandon. That sounds like a very interesting option at this point. Or, let's see. I could, no, that, all right. I think I might not be advanced enough in my testing skills to deal with this. I think I'm gonna have to do some research or something, how to deal with this. So, I think I have wasted enough time wondering how to do this, and instead I'm just going to, I'm missing something here, am I not? Yes, I am. Okay, and no, what the heck? This is this. Declaration or statement expected. Test, that's fine. This is this here. And that is, oh, it's the opposite, that's why. C'est moi, there we go. All right, let's forget about the testing for now. I'm gonna have to think about it. And figure out a strategy. So if we want to keep working on this though, let's see here. I've got this implemented, I've got this implemented. The thing is, I'm not confident about my implementation. I don't know that it's doing what it's supposed to do properly. Default policy here. I mean, I'm pretty sure I've implemented it properly, but I'm not 100% sure. Get random int inclusive, get possible actions. Get possible actions. Okay, hold on. Get possible actions is takes in a state and it returns all possible actions. I could test that. But that's pretty low level stuff. Where is that one? Yeah, this is the one I'm worried about, default policy. This is the one that actually does the simulation, and default policy calls that returns the reward. So I guess expand is also a problem because we're calling, no, not expand, tree policy, right? Tree policy, find best child. Best child is also a worry. Like, I'm not sure. Hey, hold on, this might be able, we might be able to test this. We might be able to test this. Because we're not using any randomness for this algorithm here. Oh, and yeah, we are here, but it's just like an edge case here. All right, just for kicks, just for fun. If we were to, oh, what's going on here? Cannot find name state. Oh, I forgot about that. That is a bummer. See this cool little tool, Quokka, doesn't read the declaration file. So right now it's saying, hey dude, where's state and action? Where am I even getting action from? I don't know, but it knows about it, and it's wondering where it's supposed to get its definition from. Oh, so I thought I was doing a good thing by centralizing that here, but now it prevents me from using this cool tool. Okay, maybe. Let's see. If I want to test this anyways, I actually need to have some kind of a tree built. Yeah, this is why I was thinking I was needing to get some actual testing done. Otherwise, I could blindly implement that backup negamax function. Why don't we do that? Let's take for granted that everything else is working properly and just implement this. So what does that do? Let's see. We're taking in a node. Which node? Where are we getting this? Where are we calling this? Okay, so we're choosing a node. We're running a simulation in that node. That gives us a reward. We take in that node in that reward, and we call back up with that. Okay, so while node is not null, why would the node be null? Oh, okay, we're mutating this. So all the way up to until we get to the root. Oh, so now I realize we actually need a parent property on our MCTS node. So we've got a children, we need a parent. It's going to be an MCTS node, or it could be null. All right. Now that means that when we're creating it, we need to tell it. We need to say who the parent is. So I might as well not even worry about putting that here. Hey, Lumi. How you doing? Could do this. Read only. parent of type MCTS node. Do I make it a default? No, I don't. I'm just going to do this. I'm making a 3x3 tic-tac-toe playing bot. I'm making a an ultimate tic-tac-toe playing bot. So ultimate tic-tac-toe is actually 9 games of tic-tac-toe inside a game of tic-tac-toe. I don't know if you know what it is, but I can just briefly show you. All right, so look at this board here. The way it works, yeah, yeah, let me explain. So you basically play, you see how each of these are a tic-tac-toe game? So the idea is to win the meta game, the overall tic-tac-toe game. The way to have an X or an O in each of these squares is to actually win the small tic-tac-toe game that's inside it. So that's the basic principle. The one thing that makes it really interesting on top of that is that you can only play, it's hard to explain. Okay, let me just give you an example. So let's say we're starting the game, the board is blank, completely empty. I'm player X, so I get to choose where I'm going to play. Fine, so let's say I play right here. So the upper left board, but I choose to play in the lower right square, so I get an X here. Now the opponent, the player going next, O, will have to play in this board here, lower right. Why? Because I played in the lower right square. So let's say he goes ahead and he plays his O right here in the middle left square. I would then have to play my next move in the middle left board here, right? So then let's say I put it in the upper right corner. I put an X here. Then O would have to play in the upper right board here. So I hope that kind of explains. And then, the winner still has to have the same thing, right? You need the X's and O's and a row of 3 or diagonal or whatever. So it's pretty interesting. It's pretty interesting. It is a cool challenge. I wrote a bot for this game about a year and a half ago in JavaScript, TypeScript, JavaScript, compiled to JavaScript, obviously, and it does quite well in the ranking. I'm ranked. What am I ranked? Like I'm ranked 200. No, I'm ranked 300 and something for the entire. This is just the ranking you see here is for the Gold League, but there's like different leagues. So overall, I think there's over 2,000 players, and I'm ranked like 300 and something. And it doesn't seem that great, but when you consider that most of the bots that are better than mine are implemented in like C or C++, faster languages, I'm pretty proud. But my implementation, the one I did about a year and a half ago, it's all using objects and multi-dimensional arrays and a lot of iterations and nested for loops and things like that. So now what I'm trying to do is change my game representation completely to using bitboards, right? And using bit masks and stuff like that. Yeah, yeah. So that's what I'm doing. And I'm trying to I figured I would write proper tests for this, and so all you're doing is optimization or also a different. I'm actually using the same kind of algorithm, the Monte Carlo tree search algorithm. I think it's the best kind of algorithm for this problem space, but I am optimizing the algorithm itself as well. So I'm optimizing my game representation, but I'm also optimizing the overall algorithm, I guess. And yeah, what is it that I wanted to do? Yeah, so okay. Let me show you. Have you ever implemented a Monte Carlo tree search algorithm? Not many people have. It's kind of specific to very specific problems, right? Yeah, it's pretty cool. I mean, I have no doubt that you're familiar with like tree search algorithms. So it is a tree search algorithm. It is, let me show you. Yeah, it's really cool. It's a lot of fun. It's non-trivial to implement. It's a Monte Carlo algorithm, right? It's a tree search, but Monte Carlo algorithm. So there's a lot of randomness involved. So it's kind of hard to test. There's a lot of parts to this algorithm, and it's kind of hard to see by looking at the results whether or not there's a bug in somewhere and it's not doing what it's supposed to do. Let me show you. This is the general, and that should be enough, I think, for you to grok what is going on. So you start off with a node that has your game state. You choose which one of the children node you want to run a simulation from. Now, if there's two things that are going to happen here. Looking at your state and your children node, you'll have either expended all possible actions from that state. And if that's the case, you just skip the step here. You go on to simulating. But maybe you haven't expended all possible children node. So if that's the case, you expand and you run a simulation from that newly created children node. Your simulation is it's a Monte Carlo simulation, right? So basically, start off from your children node, then you go, okay, what are the possible actions for player X or whatever? And then you randomly choose one, apply it to the state, boom, you end up with a new state. Then, what are the possible actions for that, the next player? And then you expand and simulate until you get to a result. And you need to score the result according to who you're doing this simulation from. So if it's player X's turn and what we want to do is tell player X what he should be choosing in terms of actions, well, you need to score the result from his perspective. So let's say you do the entire simulation and player X ends up losing in that simulation. Well, then you might score it as a -1, for instance. And then you back propagate that all the way up to this, to your root node, if you will. And you're keeping in each node, you're keeping track of the accumulated reward, and you're keeping track of the number of times the node was visited. And those two informations are important to determine how you're choosing which node to run simulations on. That's the crux of the Monte Carlo tree search simulation, especially the most commonly used variant of it, the UCT algorithm. It uses upper confidence bounds. I don't know if these things are familiar to you or not. So it is biased towards past successes, but not too much. It also, and that's the idea with the upper confidence bound UCB1 algorithm. You're seeing it right here, is that it tries to balance exploration and exploitation. So yes, it wants to keep in mind what moves have seemed to end up in a winning state in the past, but it also wants to try out new things because there might be better options still out there to explore. So this here is supposed to balance these two out and make sure that your exploration of the tree, your simulations and all that are done in an optimized way where you're focusing, doing a lot of simulations down the path that seems to be the most promising, so that your expected result is more. You can have more confidence in the expected result, right? Because if it just runs one simulation and it's random, it's a Monte Carlo simulation, then you can't have much confidence in the result, right? But if it ran like thousands of stimulation down that tree, down that action uh, path, then yeah, you can be pretty confident that it's um, a good choice, a good action to take at this point. But at the same time, you don't want to just go down this one path over and over and over again, just because it seems to be slightly better than just playing at random, when there might be right next to it a better choice. So you need to kind of once in a while branch out and try new things, right? So that's what the algorithm does. The problem I'm having is that it's really hard to test. It's really hard to write tests for. Um, all these parts work together, and there's randomness involved, and it's kind of hard to know if you've implemented everything properly. So I've got everything done now. I've got everything implemented, but not tested up to this last function, the backup. Actually, this is the one, since we're using negamax here. The backup negamax function is the one I'm left to implement, but I haven't really tested properly the rest of the algorithm so far, so that's going to be a bit of a challenge for me. If you're serious about giving this a try, I highly recommend this research paper. A survey of Monte Carlo research methods came out in 2012. Now, I don't remember where I got it from, but if you do a search on Google for a survey of Monte Carlo research methods, you'll find it, and it's available for free. Yeah, to test, you'd probably want to check, for example, that your randomness is uniform, or the algorithm part that's not dependent on randomness separately, to see if it behaves as expected. Yeah, that's kind of what I was thinking. Now, I'm using math.random, so technically we know that it's uniform-ish, right? It's not going to get better than that anyways, unless I start... yeah, it is uniform. For all intents and purposes, it is uniform. I've done some tests. I've actually done some pretty cool visualization. Um, well, the recent implementations of math.random are uniform. Like, for all intents and purposes, they are. It used to be. It used to be that in some browsers, it wasn't implemented in the same way in each browser, and it used to be that, yeah, you could get some patterns out of it. But now, it's using, what is that thing called again? I forget what it's called, but it's using an algorithm that's uniform. That your conversion from float to discrete value stays uniform. That's a good point, though. I should be testing for that. I should be testing for that. Yeah. Anyways, so back to our... There it is. Backup negamax. All right, so let's implement this. While v is not null, do... Let me just put that on the side maybe here. That, oof, that's not a lot of screen real estate. Let's just do this then. Backup. All right. So while v being our node is not null, so yeah, so that's cool. That'll just work fine if node is null, then that'll return false. Now nv So we need a variable here. +1 Q. I think N is the number of visits. Q is the reward. No, this would be the reward. Crap, hold on. That's the thing with math notation, eh? I am not used to it. Q, blah, 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 each node V is bar pieces. This is total simulation reward, QV, a vector of real values. And the visit count. Yeah, I think I understand the algorithm can be interrupted at any point to give a best guess at the more performant it is, the better the result. Exactly, that's exactly it. Of course, it may be possible to further reduce the problem size to increase the probability of making good choices. Absolutely, using domain knowledge, as you are saying, for sure. But that's I would say that if that's your intent, if you're going to spend if you're going to go through the trouble of implementing like a basically what do you call that, a forget that, like an evaluation function using domain knowledge, right? Then you might as well just implement it, not implement a Monte Carlo tree search algorithm, but just go ahead and use like a minimax, negamax implementation. Well, I might no, that's not. It's too much of a blanket statement what I just said. But like the big um, plus or benefit from the Monte Carlo tree search algorithm is that you don't need any domain knowledge. You don't. You can implement it without actually knowing how to play the game. Well, yeah, it's true because all you really need to know is how to represent the game state and how to apply an action to the game state. As long as you can feed that to the algorithm, you don't need to know the strategies. You don't need to know what are the best moves in certain situations. You don't, because it'll just try everything, right? At random, thousands and thousands of time, and you'll end up with the best possibilities as long as you have enough compute time, and that's the problem. So yeah, I guess you're right. If you do if you do use an evaluation function instead of going through an entire playthrough simulation, but then you couldn't call it a Monte Carlo tree search anymore because you're kind of taking away the Monte Carlo part of it, right? Yeah, you might. There are optimizations. Actually, I think this research paper goes into optimizations. Yeah, see, there you go. There's all kinds of enhancements. No, it's not against the rules. Absolutely not. You could. You certainly could. All right, so move pruning is one of them. And that's also something that's used commonly, I think, in alpha, beta. Uh, oh, there you go. It talks about it. Algorithms. Um, let's see here. No, those are all moves first, permutations. Selection, transpositions. Yeah, that's true. Move groups. I remember seeing these. Tree policy enhancements. One of the biggest, because I've tried a few of these enhancements, and the one that gave me the most bang for my buck, if I can say that, is basically not a trans. What am I saying? Oh, how do you call that? Hold on. I'll probably see it here somewhere. Do, do, do. I want to say a transposition table, but I don't think that's right. A lookup table, there you go. Um, yeah, where you get to persist some of the states. So you're not starting your simulations over from nothing all the time, but you are actually keeping previous knowledge from one call of the algorithm to the next. No, where do they have? I'm pretty sure it talks about this here, but somewhere it would be in the selection. Cutoff, progressive history, history heuristic, parameter tuning, progressive bias, search seedings, transpositions, move groups, decisive. That's weird. Oh, I guess transposition tables. Yeah, okay, so it would be in here. It would be included in here, kind of. Move pruning. Yeah, anyways, there's a bunch of stuff you can do. Oh, there you go. See, rule-based simulation policy. That kind of goes with what you were saying. Evaluation function, right? Oh yeah, last good replies, another. There's like a bunch of things, but the thing is, a lot of those enhancements will give you like slightly better results in very specific kind of situations. In other ones, it actually ends up being a hindrance. Like the results won't be as good. It's really hard to find out what works properly. I think this is one of the most promising thing, parallelization. The problem is that on coding game, you only have one thread. So one thread, one process. You can't really use this. 3x3 tic-tac-toe only has 138 ending board variations, so you may be able to build a lookup table to quickly check for game and etc. Yeah, well, I know that one game of like I've built an AI for just a simple game of tic-tac-toe, and that was using just an alphabet tree search. So you basically end up with your AI um, actually populating an entire game tree. Like tic-tac-toe by itself is a small enough game that today's computers can generate and look up an entire game tree for it using a few optimizations. And that's what I ended up doing. Now the question is, could we kind of hard code that? That's an interesting thing I could explore. I assume that your algorithm right now needs to enumerate the set of moves you can make and to check for game termination, win, lose, or draw. And if you make either of these faster, then you can run more simulations, then you can get better results, better suggestions, for sure. That's what's behind my rewrite of my original algorithm. So just to give you an example, before I used to well, with my current, the one that's running on the server right now, implementation of the algorithm, I would, let me just get back to, I represented the board as a two-dimensional array. Uh, and each item in the array is a square, basically, right? And I would store either, I think a 0 would be an empty square, a 1 would be player X, and a -1 would be player O, something like that, right? And then I probably had, um, actually, it was either a three-dimensional array, or no, actually four-dimensional, what would you call it? Like, I'm not too sure whether I had a separate array for the meta game, for the overall game. But anyways, I had arrays. Like I had arrays with each item representing the squares and all that. And then I would need to iterate through each. So yeah, wasn't the most efficient. Now, what I'm doing, I'll just give you an example of my board representation. Where did I'm going to need this here. Let's see, I've got this here maybe. Oh no, I've got this in here. All right, I'm going to need to. That's not the best example actually. Let's go in one of the test files I had started to write. There you go. So here my entire board for the entire game. I'm implementing it as an int32 array of 9, 10, sorry. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, of 10 items, 10 32 int 32s basically. Each of which represents a small board, and one represents the entire big board. So what you're seeing here, this one to this one, the first 18 bits, so bits 0 to 17, represent a square in the board. These are for the O player, and this is for the X player. So if I had a 1 here, this would be index 0, so it would be the big board. On the big board, it would be the upper left board, and then I know that O would have an O in index 0, so the upper left corner. So if I just, it would be here. So O would have one right here. Yeah, I read about that too. I'm just reading what you're saying about typed arrays being actually slower than just standard arrays, and especially for small arrays. I have read about that too, and especially a while ago. I've read some stuff recently that they say they improved it. So really, I don't know. JS engines have a special path for arrays of int arrays. Yeah. So I'm probably going to have to test this. And now let's not forget that this is not going to be running in the browser. This is going to be running on Node. So, well, it's using V8. So probably same thing as Chrome, right? It's going to be dealing with it the same way Chrome would deal with it. So anyways, I don't know. I don't know. It's going to take some testing, but yeah, I don't know. So I'm using bit masks for determining, whether a game is won or is drawn or whatever. Here, this one here represents the entire board, so, and I've got an extra 9 bits here assigned for drawn boards, which you don't have for the small boards because these represent each little squares, and these represent each big square in the entire game. Anyway, so this should be much faster, right? As before, I had to kind of iterate through an entire 2D array and trying to figure out if it was, how do you check win condition? Good question. Let me just, this would be in default policy, has one, where do I get these from? I get them from utils for now, okay. All right, so I've got, these are my bit masks, right, for each winning condition. So you can see here, this is like the top row, the middle row, the bottom row, and now this is like the left column, the right column, the middle column, then the diagonals. So this is my algorithm here, going through this array, and I'm checking to see if, so I'm passing in the small board and the player. I want to check 4 if he's 1. And the check actually, this is kind of because of the way I'm representing the board and the way I'm getting the player. Player O will end up being 0 here, and player X will end up being a higher number than 0. So if it's player X, basically, that's what's saying, that's what this means here, then we do, let's see, we take the small board, and small board, remember, is basically the first 18 bits, so bits 0 to 17, where the first 9 are for O player, and the next 9 are for X player. So I'm basically just, if it's player X, then I need to shift. I'm ending and shifting so that, we're comparing these against the right set of bits. And if it's the O player, then it's really easy. You don't even need to shift. You just compare it against that. So it's pretty simple, and it's a lot less, there's a lot less computing power being used than in my previous implementation using, nested arrays. Oh, cool. I'm open to some ideas. How could I optimize it even more? Because this is all pretty much new to me, right? I am really not used to using bitwise operators and bit boards and stuff like that. For of is rather slow compared to just a for loop. Are you sure about that? I seem to remember reading some articles on recently, because this, I know it's been true traditionally, but I think in the most recent implementations of V8, it's pretty optimized. Now let's take a look at this. For of versus for performance. Let's try to find something that's something that is relatively recent. How old is this one? It's about a year old. Reduce versus for loop versus for each. No, that's not what we want. What does this say here? Looping over an array. Okay, this is for loop, 10 microseconds. For of, 110 microseconds. For each, 77 microseconds. While, 11 microseconds. So, according to this here, the for loop is 10 times faster than the for of loop, but we're talking about microseconds. Microseconds. That's like smaller than nanoseconds, isn't it? Hold on. Microseconds. That's 1 to the power 6. That one, yeah, 1e6, right? Okay, yeah. Nanosecond. Oh yeah, so no, microseconds are. So milliseconds are 3, so that's 6, then that's 3. Okay, so I get it. Yeah, it's still pretty small though. I don't know how much we'd be squeezing out of that, but I mean, might be worth doing, I don't know. If you do substantial work in the body, well, this is the amount of work I'm doing in here. Unroll the whole loop. What do you mean by that? It's just oh yeah, okay, I see what you mean. Actually hard code the yeah. Oh yeah. Interesting. It should be even faster, yeah. Then again, looping 10,000 times here only took 10 microseconds. I, I don't know how much how much time I would be saving. Use bit operators instead to implement that. Yeah. Interesting ideas, yeah. Oh, yeah. Yeah, I would be. The thing is, I'm not calling this function all that often. Um, well, I mean, relatively compared to some of the other. But yeah, it's an interesting concept that I might be able to apply in some other places that are um more that are called more often. Oh no. I don't. Oh, hold on. Do I run it? Hold on. Do I run this on every move? No, I guess you're right. Yeah, I am because I need to know if I am running it on every move. You're right. You're absolutely right. There's no choice, right? So yeah, I am. No, so it could be worth doing. Interesting. Interesting. All right. All these not null. Do n. Okay, this is what I was trying to figure out now. N is a visit count. Node reward value QV may be treated as a vector of values for each player. QVP should circumstances dictate. How do you traverse the tree? Back propagate any object allocations? Yeah, my nodes are implemented as a class. I've got this here. So back propagating, that's the one thing that I had left to do. That's what I'm working out on now. Backup Negamax. Traversing the tree, I'm doing in tree policy. Hold on. All right, so while node is not terminal, if the node is not fully expanded, so if there's some moves that haven't been explored yet, children that haven't been created, then I expand it. So expand just basically creates a new node, a new child node, and you return it. If if the node has been fully expanded, then what you do is you look at all the children, and using the UCT, the upper confidence bound algorithm, you choose one of the child to run the simulation from. Well, actually, and that's not true. You choose one of the child, then you look to see if it's fully expanded. If it isn't, you expand it, and then you run the simulation from there. So that's how you basically traverse the tree. So the idea is you keep going down the tree until you find a node that wasn't completely expanded. Then you expand it, then you run a simulation from there. And then you back propagate the results. That's the overall principle here. If you're interested, I made an NPM library for a generic Monte Carlo tree search algorithm that works with any two-player game similar to tic-tac-toe in the sense that it's you can see everything, right? Nothing's hidden, and there's no like dice rolling or anything like that. So it's just like a set. The rules are set. The state is set. So something like tic-tac-toe would work. Something like chess would work. Checkers. Any kind of game like that. This is it right here. Macau. It's on NPM. You can look. Let me just paste that here. If you want to see how I implemented it before. Now you won't find anything specific to tic-tac-toe or Ultimate-Tic-Tac-Toe in that library. It's a generic. It's meant to be used for any different kind of games. So obviously it's not like as optimized as it could be. If you're building the Monte Carlo tree search specifically for a specific game, I guess. But it gives you an idea of how I implemented it before. I am actually mostly just debating what language I am going to write my version in. Probably going to do it Clojure because I want to use some FB. Yeah, sure. I'd do it in Rust, but that's the next language I want to learn is Rust. All right, so let's look at what I did in the back propagate here. Yeah, no doubt. I'm guessing it is more work. All right, so what am I doing here? I'm passing in the state. I'm passing in a score. Does that jive with what? Yeah, that's right. What do I have here? Back up. Yeah, node, reward, cool. Uh, then what do I do with this? Decaying parameter. Oh yeah, right. That is one of the enhancements, I think, that they were discussing. Let's take a look here. Control F. Decaying. Decaying reward, yeah. Is a modification to the backpropagation process in which the reward value is multiplied by some constant that is smaller. What? That is bigger than 0 or smaller than 1 between each node in order to weigh early wins more heavily than later wins. This was proposed alongside UCT. Yeah, makes sense. Score bonus. In a normal implementation of UCT, the values backpropagated are in the interval 0 to 1. I think I'm doing it -1 to 1 because I need a way to represent draws, which are 0 in my case. A loss is -1, a win is 1. So then there is no way to distinguish between strong wins and weak wins. One way of introducing this is to backpropagate a value in the interval 0 and whatever the symbol is for a loss and something to 1 for a win, with the strongest win scoring 1 and the weakest win scoring that weird symbol. This scheme was tested for sums of switches, but did not improve playing strength. So that's the thing with a lot of these ideas for enhancing the Monte Carlo tree search algorithm. A lot of them don't end up helping. Can you not use libraries on coding game? You can. Yeah, well, I mean, I can use, I don't know if you can with every language. It depends how you're doing it, but coding game allows you to use an external IDE to do your thing. So I'm actually writing this in TypeScript, even though it's not supported by coding game, but I'm using rollup to package all my stuff into one file, and then that's what I shoot over to coding game. So yeah, I can definitely include some libraries in there. No, you don't have to paste it in. There's actually a nice little sync thing that they do. It uses a Chrome extension, so and it's live. You don't even need to hit like a sync button or anything like that. It just detects whenever your file has changed. So yeah, I have used some libraries in the past, I think, on coding game. But I also like to implement stuff myself. For this anyways, for coding game. Alright, what was I doing? I'm looking at this decaying reward. Transposition table updates. Child, discuss a variety of strategies for handling transpositions so that the information can be shared between different nodes corresponding to the same state. Each variation showed improvements over its predecessors, although the computational cost of UCT3 was large. And that is the problem. Sometimes some of the enhancements that are proposed, they do increase the quality of the results you're getting for, let's say, a certain simulation. The problem is that they increase the computational cost in a way that reduces the number of simulation you can actually run, and to a point where sometimes the benefit, the cost outweighs the benefit. So yeah, your simulations are slightly more meaningful, but it's quite a bit costly to get that better simulation done. So, you end up being able to run like only 75% of the simulations that you were able to run before. So in the end, the result is not as good. All right, so I'm probably going to throw that in too, because that makes a lot of sense and it doesn't add much to computation, making early wins worth more than later wins. Right, so if we had to, let's imagine two branches that have an equal chance of leading to a win, but one will lead to a win in like 3 turns and the other one in like 16, right? Or something like that. So obviously you would want to pick the one that's going to lead to a win sooner. Do you also measure the number of losses? You don't. But by extension, you kind of do, because you're calculating the number of wins. Well, not the number of wins as much as a reward score, which, is heavily dependent on. Well, hold on. Yeah. Well, by extension, you are. It's because I'm using Negamax to back up the reward. So you are. Oh yeah, you do. That was one of the problems when I first implemented this like a year and a half ago, and that's why I changed my scheme where losses were worth -1 and draws were worth 0, and a win is worth 1. Yep. Where is that thing? There it is. Okay. So while node. Whew. Sorry. All right, so I get the node MCTS state visits. I'm incrementing the visit count, and I am adding to the reward with the reward I'm passing in there. Flip the reward score. All right, and the reason I'm doing that is because of the Negamax thing. So if I compare, just to see how well this compares to what we're actually doing here. Come on. Where is it? Okay. So so the number of visits now becomes the number of visits plus 1. That's what I'm doing here. This reward becomes the reward that we had plus the score we're passing in. Now we flip the reward. That's right. And the node becomes, yeah, okay, that's exactly what I did here, except that I'm allowing for a decay reward. Decay. I'm not going to do that now, though. So I can pretty much just copy this. This pretty simple implementation. I'm not going to change much in there, except that I'm using a slightly different visits. Let's see. I do have visits here, but I had it as a read-only. I need to be able to change that. Do I want to be able to do it directly? Or do I want to set some sort of setter and set visits? Would that work? Values type number. No, it would not work. So I might as well. Yeah, you know what? Why don't I actually call this increment visit or add visit? How's that? Add visit. I like it. Void. And this dot visits plus plus. Oh, because I got it as read-only. Crap. Then I would need it as what's the way to do this? If I want to... Alright, I don't have a choice to do it that way, I guess. I do this as visits, plus plus, and then I can just do a getter here. Get visits. Something like that would come to the same thing. Yep. Okay. So now I can do node dot add visit. There we go. And okay. Should be about the same thing too. If I've got this reward, let's do private reward. And we'll make a getter for that. Get reward number. Return this that reward, and we'll say add reward. This will take a value, type number, return void, this dot reward plus equal value. Add reward. Like that. Flip the reward. decay the reward. I'm not going to worry about that for now. Might implement that, might not. We'll see. Now node is going to be node dot parent. Did I not? So this could be MCT, or it could be null, obviously. Mm-hmm. And I think that's it. So that was pretty easy to implement. So that would mean yeah, and that's the reason why we need a scheme where we have values, wins that are worth +1 and losses that are worth -1, because we're using backup negamax. Because if we were just using something that had, like, let's say, losses are worth 0 and wins are worth 1, then if we had oh wait, this could technically work. Because I'd have to think about this. Well, whatever. I know that this works. So I'm going to keep it like that. All right, now I just need to figure a way to test this properly. And this is easier said than done. Okay, what's the problem here? Expected 3 arguments, but got 2. I am missing the parent. Yes, that is true. That is very true. So let's see. I'm starting off with the root node, and well, there are no parents. You are the parent, so that's fine. But when I am creating a child node, where am I adding a child? I'm adding a child in the expand. Here we go, and this is where we need to add our parent. The parent here is node. There we go. Mm-hmm. All right. So Lumi, if you're actually going to do this, you should register on Code and Game and actually implement it there. That way you'll be able to compete against my bot. That'd be cool. And other people's bots, of course. Yeah, awesome. I wonder, I don't know if Coding Game has, let's see here. Yeah, you're thinking about doing it in Rust too, eh? Trying to get that, your Rust is a bit rusty. My Rust is worse than Rusty. I've never used it. All right, let's say I turn this off. Pretty sure they have Rust. Yep, they've got Rust. They've got Clojure. What were you thinking of using at first? You said you were debating using... Oh, Clojure, that's right. So they have Clojure. I'm pretty sure they have Haskell too. Yeah, Haskell. If we're dealing with functional programming languages, they probably have what's that other one? I think Kotlin is another one that's pretty functional. And what's the one I'm thinking of? That is basically the ancestor of all these. Oh, Kotlin isn't functional? I thought it was. Okay. Oh, Scala, whatever. What is the ancestor of all these languages that use like a bunch of parentheses all over the place? Pascal, no. I can't remember what it's called, but it did. Oh, if it was here, I would know. Oh, Lisp. There you go. Lisp. Yeah. No, it's not there. But they do have Rust. They have C++. They have C Sharp. They have C, Ruby, PHP, Perl. They've got a... Oh, man, they have VBNet, Visual Basic. Pascal. Python, of course. Oh, cool. People like to pretend Rust is functional, but it isn't actually. Oh, they do? I never thought it was functional. I know that they I think people say that because it doesn't have what is it, null? I think it's not. It doesn't use null. It forces you to use like a maybe or something. So that might be why some people say that. Yeah, an optional type. That's right. I remember seeing that. I've never coded in Rust, but I did. Um, I think I saw a few code bases and I watched a few videos. All right, man. I'm gonna have to go. So you'll probably have your butt ready by tomorrow, right? uh, I'm still I'm still racking my brain, trying to think of a good way to test all these. Um, yeah, maybe I'll figure some. Oh, I need something here too. Oh, that's my test. All right. Anyways, I really have to go. So I'm looking forward to seeing what you come up with. Let me know if, as I said, try to write functions without too many dependencies and then test them individually. Yeah, definitely makes testing easier. That's for sure, right? Okay, cool. So let me know. Shoot me a. Did we connect on Twitter or something else? Well, anyways, worst case, just send me a whisper or whatever direct message in Twitter. Not Twitter. On Twitch. Yeah, that's what I meant. Sure. Yeah. Same with me. Let me know. Like if are you gonna Oh, I could friend you on Discord. I could friend you on Discord. Let me see. How does this work again? Search. No, that's not it. Direct messages. Add a server. Nope, that's not it. What the heck is the friends? Maybe friends? No. I use Discord, but not all that much. I always have it on though. How do you send a direct message? Server discovery, that's not it either. Home. Well, anyways, worst case, like if you've got your bot up and running, let me know. Send me a message on Twitch. I'll be looking for that. Let's see. All right. Okay, so I gotta go. This was fun. See you next week, maybe. All right.